Hey YouTube. In general, when you want to send a lot of electric power, you have to use some pretty heavy-duty cable in order to handle all that current. So how is it that I can power this halogen light bulb using these very small 30-gauge conductors? What I've built is a small model of an electrical distribution network. When power needs to be shipped long distances, the thickness of the copper or aluminum wire makes a big difference in the price. The thicker the wire is, the more expensive the entire network will be. To use smaller wires, high voltage transformers are put on either end of the network. These high voltage transformers are necessary because they step up the voltage and step down the current at the same ratio. If the voltage goes up 10 times, the current also correspondingly goes down 10 times. This allows you to move the same wattage of electricity over the same distance, but at a much lower current. This means that you can use much smaller wires and save money on your electrical distribution. Using a clamp-on ammeter, we can directly measure the current in both halves of the system. On the low voltage side, the current's about 3.5 amps. That requires a reasonably sized conductor. On the high voltage side, however, the current is only half an amp. That allows me to use a much smaller conductor to transmit the same amount of electrical power. There is, however, a downside to using high voltage for electrical transmission. It's not particularly safe. They have to use very large insulators and string the wires high above the ground to prevent them from coming in contact with people or vehicles. At low voltages, like you'd find in your household, insulation can be made very cheaply and doesn't take up a whole lot of room. I hope you found this interesting. If you'd like to see more like this, check out my channel. Thanks for watching.